I think that Syntropy's mission, our place in the world, is going to wind up being that we only support projects that are pushing humanity and the environment forward. So like we pick and chose on purpose Bitcoin Green because it's going to help our environment. We chose our data center on purpose because it's going to help our environment. We're going to choose coins that have a humanitarian component to it, whether it's simply taking down the banking cartel or taking down, the centralized social media, or hopefully feeding children and planting trees. I want to only support projects that are in the betterment of man and not driven on money. And I think that we can be a market maker and we can set the standard. If we become the authority in industry for mining, we can set the standard that, you want to get on our platform, you better be doing something good. And if you're not doing anything good and you just some guy out there or some idea that's going to raise a buck to do something, I don't give a shit. And we don't care how much money is being made. It's not going to be in our sphere.
Brilliant.
Because Bitcoin Green is $2 right now, and they very easily could replace Litecoin and Bitcoin Cash because it renders Bitcoin Lite and Bitcoin Cash irrelevant because they came out because it makes it super fast, efficient transactions in minutes instead of hours. Bitcoin Green does that, and it helps our planet at the same time. So Litecoin was $300 a month or two ago. Bitcoin Green's $2. Bitcoin Cash was $2,800, right? Bitcoin Green's $2, and both Bitcoin Cash and Litecoin are destroying our planet. It's proof of work. And in cryptocurrency, there's two different terms. There's users and then there's miners. And if you look at traditional proof of work mining, whether it's Bitcoin or the other cryptocurrency 1.0s, there's actually a conflict between the miners and the users, because the users, of course, want the fast, efficient transactions that are going to be really, really cheap and very low in fees. But the proof of work mining, there's a conflict because the miners themselves want higher fees. And they don't really necessarily care about speed. They just want to get a higher fee. They want to be able to mine more. So inherently, there's a conflict between the two different opposing sides, and they're not working in unison. Proof of work is actually quite different because, as you mentioned, there's a stakeholder. And proof of work essentially means that you have to buy 1,000 coins, 10,000, 20,000 coins. You buy a substantial amount of coins, and you stake them. So you have a vested interest or a vested stake in the community. But there's no conflict there because you don't need these massive, super high-speed computers to process complicated algorithms. You just need a typical web server. You have to be online. You have to have a connection. And these servers last 7, 10, 12 years versus proof of work. Sometimes your equipment can only last 3 to 6 months. And that conflict goes away. The miners and the users work in unison for the betterment of that coin or that token or that community. They all want fast transactions. They all want, inexpensive fees because it's just a different thought process.
So proof of stake, you mentioned the hardware, and you're saying that kind of server lasts 10 to 12 years, let's say 10 years. And then proof of work, it lasts 6 months, potentially. How's that? How do you weigh that? How do you measure that? And what are the factors that play into that difference there from a technical perspective?
Let me show you a visual. Hold on 1 second. I'm going to grab something.
Yep.
Okay. All right, show and tell time. 2011, right? Clint and I, senior developer of Syntropy, built this proof of work machine. Now, it looks very ancient because it is, and hopefully one day it'll be in the Bitcoin Museum. But essentially, what it is back then we took the fastest equipment we could buy, and we bought these video cards, as you can see here, GPU cards, to process Bitcoin. And what we did was we initially had these, big computers that were very expensive for the hardware and all the equipment. And essentially, we realized that it was more cost effective to just simply buy the parts and put them in the crate. Why a crate? Because crate is $10, and because it can breathe. We can stack these to the ceiling, and we can use a lot of fans to get the air blowing through. But the problem we're finding is that these video cards were only manufactured in one place in the world, one warehouse in China. Everybody, all the miners, everybody in the world, including graphics people and video people, wanted these cards. They became extraordinarily expensive. So we were noticing that these cards would initially get a lifespan of 14 months, and then 12 months, and then 8 and 4. And eventually we were like, at this rate, we may not even get a month or two out of these cards. And we're buying these cards all the way from China, having shipped, get to the customs, get here, and build these machines for what? For a month or two, and then all of a sudden they become irrelevant. So not only from an economic standpoint, we were thinking, this is ridiculous. I want to buy equipment every month. But was tugging on my environmental consciousness in my heart. I was like, what is this going to do for the planet? That every month or 2 or 3 months, I'm going to start throwing all this equipment in the landfill somewhere. No one wants to buy it after it's been used. And it becomes irrelevant so quick, because the reason why it becomes relevant so quick is because from a technical standpoint, Bitcoin has an algorithm that essentially is called proof of work. And what you do is you try to solve a complex puzzle or equation. And when you solve that, the first to solve that equation and to verify a transaction and clear a transaction is awarded a new Bitcoin. Well, and then there's a part of luck as well in that process. But so if you think about it, you have all these computers competing over solving a complex puzzle, mathematical equation as soon as possible. So you have to build a faster and faster and faster computer. And
okay,
so
because I heard you're right. So just to hold you there, what you're doing as a miner, you're competing for transactions, right? You're competing for solving these problems. So you're grabbing
exactly.
a problem to solve. The first one who solves it gets awarded the transaction, even though other computers might be working on the same problem, correct?
Exactly. And only one's going to win. Unless it's a mining pool, then everybody within the mining pool shares that profit. But essentially, think of how inefficient that is. You've got, millions of miners worldwide that are all competing, to solve the equation the fastest. And the fastest computer is going to likely process that, the most efficient and the fastest. So you're constantly fighting to build a faster and faster and faster computer. And that algorithm is constantly shifting, so the difficulty goes up and the reward comes down. So you're fighting against two things. I say the difficulty goes up means you have to get a faster and faster computer to keep up with the difficulty. Okay. So, with that, it's very inefficient. And, if you think about the fact that right now, Bitcoin's network uses more energy than 80% of the countries on the planet, more than 159 countries combined. Wow. That's pretty insane and growing exponentially. So how is that sustainable? How are you, first off, it becomes, the whole philosophy of cryptocurrency is to become a decentralized network, right? And a decentralized network makes it a lot more fair and difficult to take down, because there's more and more and more and more users on a peer-to-peer network. But if you have to build a faster and faster computer, eventually who's going to have those supercomputers? Google? Amazon?
Yeah. And all I can think of is this pile of redundant computers piling underneath as you're rising to the top, of latest hardware and speed.
Right. And so, if you can afford this massive data center, this huge warehouse full of equipment, and you have a unlimited, cheap power, And the rest of us have expensive power, and we have to buy equipment every 3 months and stand in line, 8 months to get equipment sometimes. Who's going to be running Bitcoin?
Yeah, correct. So now I understand a little better. So I didn't get why you were saying hardware becomes redundant. So we're looking at those.
Not redundant, irrelevant.
Irrelevant. There we go. So those video cards still work, but they're not fast enough to compete with the latest video card technology. Is that a right assumption?
I can use this video card to process graphics or to use it as a video card for this video session, hypothetically, right? But I can't use it for Bitcoin because, quite frankly, this machine right here, probably I could put it on in the Bitcoin network and I'd make like 10 cents a year. I have no idea how much. But
so see, now that is a pretty serious and a pretty important distinction that you're making there of how that works.
Right. Yeah. And at some point we just had to make a decision. Are we going to constantly buying equipment every 3 months and pouring money into building these machines all night, all weekend, stack them to the ceiling and just to throw them in the garbage every few months,
Yeah. And I see people put up, renting out a warehouse space and putting up computers. They don't even look like computers. They just basically, cards, just stack racks and racks and racks and racks of space, just to process.
The cloud mining companies out there that are doing proof of work, and not to name names because, they provide a very valuable service and it is profitable and for the most part. And they are supporting cryptocurrency, which I do believe in. So I'm not trying to slam what they're doing. They provide a very, very valuable service. But you'll see if you try to sign up for them, they will take your money, they'll hold your money for 4 months, and during the 4 months, they will buy your equipment likely from China, ship it over to where their mining operation is, set up your mining equipment on a network, and then you start getting paid. Well, what happens in 4 months? Well, during the course of 4 months, the Bitcoin difficulty will go up, right? And therefore your returns will come down. So when you sign up, here's my $1,000, your expectations of a return is this, but the reality is by the time you actually get your equipment through customs on your network, on the grid, you're going to make far less than you anticipated.
That makes a lot more sense to me. Okay, so I remember there was the old saying about, was it Moore's Law or something, that technology or actually hardware becomes redundant every 18 months. In the cryptocurrency world, that's probably what, 3 months or something, that it's so quickly.
It changes. I mean, yeah, back when Bitcoin's price went up to almost 20,000, I think it was at the end of the year, December or something like that, 2017, the difficulty was very, very, very high. And then now that the price has come down to 6,500 to 7,000, the difficulty has come down a little bit. So that difficulty actually fluctuates a little bit based on number of miners, based on the amount of the value and amount of coins, etc. But overall, the curve is like this, and increasingly more like this. And so that difficulty, it just gets, over time, it gets harder and harder and harder, and you need faster and faster and faster equipment.
Wow. Okay, so now that you sort of described that clearly, proof of work. Now how would you modify what you said in terms of proof of stake?
Well, first off, I should probably say that I'm not, completely against proof of work because it has a certain value. But I just find it to be extraordinarily inefficient, particularly compared to proof of stake. And so proof of stake is quite a different concept. And essentially what it means is you, as I mentioned before, you take 1,000 coins, 10,000 or 20,000. Each coin is different. And you'll take a large number of coins. You will buy a web server. You will assign an IP address, a processor, RAM, hard drive space. You'll install the operating system. You'll configure, your node with your coins, and then you'll stake it on the grid. And when you become a node on the grid, essentially you have a job role as as a proof of stake miner. And your job role is to basically process transactions for the community or for the network and deliver transactions. But you also provide another layer of decentralization, because it's a peer-to-peer network, and therefore your network, every time you add a new node, it gets a lot bigger and a lot more stable. And you also provide security, because if you had a DDoS attack where you attacked one machine, it wouldn't affect the entire network as a whole. So every time a node comes on a network, it creates another layer of decentralization, another layer of security, and frankly, a whole another layer of backup, because every single node on the grid also holds the entire ledger, the entire blockchain. So with that, that job role of processing transactions, delivering coins, and providing security, you get rewarded every single day a number of new coins that are coming into the system.
Okay, so let's get back to, all right, so I understand that. It sounds like you're saying proof of stake, you're adding a node, and if you're adding a subsequent nodes, they all form part of the same network, right? And processing power. Is this expanding the same node, but to a larger processing area? Would that be a fair statement?
No, the entire network consists of nodes. So, in the beginning,
I'm trying to find how is that different from proof of work? Isn't proof of work also nodes? No.
It is, but here's the difference.
Yeah.
Proof of work can be run on a very, just your typical web server, okay? You don't need, there's these massive GPU or application-specific chips. You just basically need just a simple web server with one processor, one RAM chip, small hard drive space, and an IP address.
Fast video card.
No, you don't need a video card. You don't need an advanced chip. You just need a web server. And these machines easily last 7 years, 10 years, sometimes more. We have machines that have been running for over 7 years that we haven't even rebooted yet. And these are very inexpensive machines that are very eco-friendly. They don't take a heck of a lot of energy. I did a presentation 2 weeks ago where I demoed a machine on site, and I can probably do that next video if you want, where I actually took a amp meter and I showed how many amps each one of these machines do. And it's very low. It's basically...
I think it'll be worthwhile doing that actually as a session, but okay, I lost you a little. So I just want to bring it back to, we're talking about proof of work and we're talking about proof of stake, right? Mm-hmm. On the one hand, proof of work, you're saying, like the machine you built there, the old Bitcoin machine you got there, right? You have the hardware, you have CPU, RAM, you got the video card. You need that, correct?
Right.
For work. Proof of stake, you're saying you don't need all that. Just draw that distinction.
A very simplified version of proof of work versus proof of stake is that proof of work gets harder and harder and harder and harder and harder and harder to accomplish. You need a faster and faster and faster computer. Proof of stake, you only need a simple web server. That's it. It never gets harder. You never have to add more processing and more RAM. You only in the future will have a little bit more hard drive space because the blockchain gets bigger and bigger. But that's it. A typical web server runs all these proof of stake nodes, and that's vastly different than these massive, mining machines that suck a tremendous amount of energy.
Okay. But there's one catch. The catch is, although proof of work is easier because you can have standard hardware as well, right? You could put it together as a machine. It will get more expensive and harder over time. So to stay ahead of the curve, you'll keep renewing your hardware to try and be competitive, correct?
Right.
And proof of stake, it doesn't have that scalability issues, although your memory might increase, the hard drive space to keep the ledger or keep a record of the ledger. But how does that play into competition? Is that a competitive environment as well?
Actually, no. The beautiful thing about proof of work is it's community based, and it's based more
proof of
on
stake, you mean? Proof of stake, you mean?
Yeah, sorry, proof of stake. The beautiful thing about proof of stake is you're not competing to have a faster and faster computer that's going to process faster than the other miner and get rewarded the new coin. You're actually sharing all new coins that come into the network. So if you have 3,000 coins a day coming into the network and you've got 100 nodes, it's going to be 30 coins each node. Regardless of how fast your server is or how fast your equipment is, as long as you're online, as long as you are, as long as you're online processing transactions and you're providing that service of decentralization, you will get an equal share of those coins coming in. It's split amongst everybody. It doesn't get awarded to one person or one machine. It gets awarded to everybody. So everybody's best interest to make the community push forward.
Right. So what it's okay, cool. I think that sounds good. There's one more question I have about that, and that is, so when you enter that space, let's say I'm new and I want to decide which one I can do both, right? So what it sounds like to me is that on the one end, it might be a less expensive, or let's say more inexpensive to get into proof of work, but it's going to be more competitive, and I need the latest hardware and need to be ahead of the curve. On the other side, proof of stake, it seems like it's more expensive to set up initially because there are more, you have to stake your coins on the network. So, but the long-term benefit is that there's no real competition, and it's there's a longer shelf life, let's say, for the hardware.
That's true and false. You're going to give you a real life example. There's a very popular proof of work machine called the Ant Miner. And the Ant Miner, the last time I checked, was doing about 14 theta hash a second. So the hashing power is really, really fast. 14 theta hash is very quick. And it was very expensive. You can't get a machine for $5,000. Typically, it's like $7,000 or more. And people would buy a lot of these machines in advance, and then they would sell it on the open market before they even use it at double the price. So, getting those machines is actually quite expensive. And the problem is, I have we bought a few of them, and a few of them, by the time they arrived, became irrelevant because it took us 9 months to actually get them from the warehouse in China. And we were one of the first in line. And by the time you ship them over from China and you get them through customs and you have to deal with customs and duty tax and everything else, you plug them into the wall, it can be 9 months later. And so then, it may take you another 6 or 9 months to even make your money back after that. So it's very, very expensive. Now, proof of stake can be very expensive because let's use Dash for an example. Dash at one point was worth $1,200 a coin. You need to buy 1,000. That's $1.2 million to run one node. The price came down. I think it's about 300 or 400. So let's say it's only 300,000 or 400,000 to run a node. The average person can't even come close to that. There's no way an average person would drop 300,000 on one coin or one node to test it. So you have to have a heck of a lot of money to do that. But there are nodes where you can buy them where they're only 10 cents. So 1,000 coins is only $100. Now, most of those are junk and they're not even worth entertaining, and you will spend more money on hardware and software and expertise. So you have to kind of find that sweet spot of what is a really good coin to stand behind, number one. Number two, what does it cost for those number of coins? To give you a really good example, we've been mining Bitcoin Green. Bitcoin Green requires 2,500 coins. It's currently a value of 1.1 Bitcoin and 1.5. So I think it's worth about 8 to 10,000 a node. So let's say it's worth 10,000 a node. Now, a mining company like ourselves, we can buy 4, 5, 6 nodes, and we can combine them in a block, and they can mine quite efficiently. The average person may not want to drop $10,000 on one node. So you're right. In that sense, it's not affordable for the average person. But some of them are.
So when did proof of stake become a thing?
Dash was the first one to build it into their code base, and I believe it was 2014 or 2015 when he actually launched it. And then there was 300 or 400 different copycats out there that took their code and perfected it and added a few other things in there, like private send, microtransactions,
Wow. Okay.
sidechains.
Yeah, I think it's good, David. It seems like there's an opportunity for quite a, I'm looking at how the world's changing and the fact that, any specialized skill from doctors to lawyers is, if it can be automated, it will be automated. And if it can't, and if a human is doing a job that can be automated, it's only a matter of time. And that job becomes the machine's work, right? So a lot of people, like even I think McLuhan back in the 60s predicted that the era of jobs was already redundant then,
Yeah.
belong to machines. They do not belong to humans. Humans have roles. They don't have jobs. So,
well, humans aren't made to be robots, and there's always that struggle that humanity has with artificial intelligence. AI is coming out, all these robots coming out. People are getting freaked out about losing their jobs, but and rightfully so. I mean, it's pretty scary. The number of jobs that are being taken away by machines, but at the current level, they're taking away mostly the robotic jobs. Humans weren't made to be robots. We were made to be creative creatures that can think, critical think, and create. And so I'm hoping it will alleviate us from all those mundane robotic jobs and allow us to be co-creators.
That's true. So any job that can be repeated, like the same move, the same something, will be automated, because that's really just a precision. Can you do the job? Yes or no? Digital, 1 zeros. Now, yeah,
for sure.
But I can see how hardware. Now, we talked about this earlier. This conversation, we talked about how hardware is becoming decentralized as well. Now, the Ubers of the world, even real estate. I mean, people are buying property for the rental community in the world. People don't want to buy houses; they want to rent. They want to travel. So it seems like hardware is going the same way, especially with proof of stake, because they can buy into, like I think you mentioned, is it I'm using the word syndicate, but it was an analogy to syndicate or company of stakeholders, right? That could share. Like there's no competition in proof of stake, right? So you could actually just grow your node base to incorporate more transactions and more coins that are of value, that you pin down as valuable transactions to process.
Right.
So tell me a bit more about that. I mean, you talked about Bitcoin Green. So are these specific coins with a specific purpose and value, or how do you see that? How do you view that?
Bitcoin Green is the very first proof of stake Bitcoin, and essentially what it means is near instantaneous transactions that happen extraordinarily fast in milliseconds that don't require very expensive and very computer intensive, processing intensive proof of work type machines. It's a proof of work based on web servers, and you basically, as I mentioned, you're staking coins. So it's going to save a tremendous amount of electricity. Essentially, Bitcoin Green right now, last time I checked, is like $2.39 compared to Bitcoin that's about $7,000.